Technological advancements have brought about a revolution in various aspects of our lives, including manufacturing and production. However, amidst these advancements, creating 3D printed firearms has emerged as a highly controversial application. A 3D printed gun, commonly known as a ghost gun, is produced using a 3D printer. Unlike traditional firearms that require skilled craftsmanship and specialized tools, 3D printed guns can be manufactured by anyone with access to a 3D printer and the necessary materials. These guns are typically composed of plastic components, created using additive manufacturing techniques to achieve intricate designs and functionalities. By utilizing plastic materials, these firearms reduce overall weight and offer enhanced concealability due to the flexibility and adaptability of the components. In this video, we will embark on a journey to unravel the mysteries behind the production of guns using 3D printers. By exploring the fundamentals of their operation, from input to output, we aim to provide you with a comprehensive understanding of their functionality. So, let's begin by delving into the basics, shall we? The process of making a 3D printed gun. The initial step in creating a 3D printed firearm involves utilizing computer-aided design software. There are numerous online resources offering detailed instructions and blueprints for various types of guns. Once the design is finalized, the subsequent stage entails selecting suitable materials for printing. Typically, high-strength plastics like ABS or nylon are employed in the production of 3D printed firearms. The choice of material is influenced by durability, strength, and printability. The gun components are then printed layer by layer using a 3D printer, necessitating patience, precision, and adherence to the design specifications. Ensuring the printer is accurately calibrated ensures precise dimensions and structural integrity. Subsequently, the printed components are meticulously assembled, involving the attachment of the barrel, trigger mechanism, and other crucial parts. Further, post-processing techniques such as sanding, polishing, and painting may be implemented to enhance the firearm's aesthetics and functionality. The digital file is the electronic signal that initiates the 3D printing process. It can be transferred to the 3D printer through a cable or wirelessly via Bluetooth or Wi-Fi, much like how we send documents to conventional printers. However, the critical distinction lies in the file's content, which contains the specifications for each firearm component. 3D printing relies on the additive manufacturing method, where layers upon layers are added to create the desired object, as opposed to traditional subtractive methods that involve removing material to form a shape. In the case of 3D printed guns, this process breathes life into the digital blueprint. Similar to how a printer driver in conventional printers interprets a computer-aided design file and translates it into a series of commands, a 3D printer follows instructions to deposit material layer by layer until the entire firearm is formed. The choice of material can vary, ranging from plastics to metals, depending on the printer's capabilities and the desired durability of the gun. Different parts of 3D printed guns. Regardless of the printing method used to make 3D printed gun parts, all printers have some basic components that work together to produce the final output. So, let's take a deep dive into the different parts of a printer and how they work. 1. Trigger. Exploring the world of 3D printing for firearm triggers requires a delicate fusion of form and function. The choice of strong and heat-resistant polymers ensures durability while maintaining a satisfying tactile response. Iterative refinements fine-tune the design, striking a harmonious balance between comfort and instantaneous responsiveness. Consider it as crafting the very essence of your firearm. 2. Hammer. Crafting a 3D printed hammer is akin to sculpting the percussionist of your firearm orchestra. It involves making intelligent material choices, such as high-strength polymers, layered with precision to achieve optimal weight and seamless integration. The design journey resembles a symphony of prototyping, ensuring this component strikes the perfect balance between strength and operational efficiency. 3. Firing pin. Picture 3D printing a firing pin as orchestrating the prima ballerina of your firearm. It's a delicate yet mighty act. They meticulously select materials with a dual personality, embodying strength and resilience, often dancing within the realm of reinforced polymers. Through iterative refinement, ensure flawless performance and a consistent and reliable pirouette on the stage of primer strikes. 4. Bolt carrier group. 3D printing a bolt carrier group, BCG, is like crafting a masterful modular component for your firearm. Each bolt, carrier, and spring performs its solo, while the enduring strength of carbon fiber-infused polymers takes center stage. The meticulous assembly of this ensemble faithfully replicates the nuanced movements necessary for the flawless harmony of proper firearm cycling. 5. Barrel. Creating a 3D printed barrel is akin to crafting a custom-tailored suit for your firearm. Utilizing high-temperature, high-strength filaments, it stands strong amidst the intense heat generated by repeated firings. With precise printing techniques and a touch of resin-based artistry, rifling patterns are meticulously carved, ensuring accuracy and a masterpiece of ballistic performance. 6. Pistol grip. In 3D printed pistol grips, the focus lies in bestowing your firearm with a customized embrace. Ergonomic preferences reign supreme, as pliable materials provide a comforting touch. With a modular design, you take on the role of the conductor, ensuring that your grip not only connects but also serves as a testament to your unique shooting style. It becomes a symphony, a gesture that transcends a mere handshake. 7. Magazine. Creating a 3D printed magazine is like composing engineering poetry. Carefully select materials that epitomize strength and flexibility, such as reinforced nylon, to ensure a dynamic yet sturdy performance. Through iterative testing, meticulously refine the feed lips and follower, crafting a seamless rhythm for the cycling of ammunition. This magazine becomes the reliable narrator of your firearm story. Materials for making 3D printed guns. When creating 3D printed guns, carefully selecting materials is crucial to ensure functionality and safety. While it is of utmost importance to approach this topic responsibly and in compliance with legal regulations, exploring the commonly used materials for 3D printing firearm components is also informative. Here are some materials that can be utilized to manufacture 3D printed guns. 1. ABS, acrylonitrile butadiene. ABS is a commonly used thermoplastic in the realm of 3D printing. Renowned for its robustness and longevity, ABS is ideal for crafting components that demand resilience and excellent impact resistance. It finds frequent application in fabricating firearm frames and grips. 2. Nylon. Nylon is a highly versatile thermoplastic known for its exceptional strength and flexibility. Its outstanding impact resistance and durability make it an ideal choice for parts that demand toughness. In 3D printed firearms, nylon finds potential application in various components such as frames, grips, and certain internal mechanisms. 3. Polycarbonate. Polycarbonate is a strong thermoplastic renowned for its exceptional impact resistance and transparency. It is particularly suitable for fabricating components that demand both strength and durability. Polycarbonate can enhance the resilience of various parts when employed in the production of 3D printed firearms. 4. Carbon fiber-filled filaments. The strength and rigidity of printed parts can be significantly enhanced by incorporating filaments infused with carbon fiber. These carbon fiber-filled materials are commonly used for critical components such as bolts and carriers, striking a balance between strength and weight. 5. Metal filaments. Some 3D printed guns can include metal filaments, a combination of metal particles, and a polymer matrix. Although these filaments are not entirely made of metal, they can give metallic properties to certain components, such as barrels or firing pins. 6. Resin, SLA/DLP. Stereolithography and digital light processing are advanced 3D printing technologies that utilize liquid resin cured by UV light. These methods excel at creating intricate and high-resolution parts, making them particularly suitable for firearm components. It's important to note that the strength and durability of resin materials can vary. So here's how a 3D printer can craft your beloved 3D printed gun. While the process may seem simple, it seamlessly integrates intricate components to produce extraordinary results. Hope you have found this video to be informative and interesting. If you do, then please don't forget to like, share, and subscribe to our channel for more such content. So, the next time you hold your 3D printed gun, remember the intricate journey it took to come to life.